welcome back to this next edition of Science Modernizers, in which we are going to proceed with the solutions of the June 2020 Mathematics Paper 2 Advanced Level. And so today we are going to solve question 2, in which in our recent video we saw question 1, and in order to see it, it's just found, just go to the next previous video, you are going to find it there. And so do not forget to click on the subscribe button to stay tuned to the channel for more of these videos shall be uploaded. So question 2, shoot to the point. What does the question really say? So question 2 says, given that y is equal to ln 4 plus x squared, find dy on dx. So from here we have given us y to be the natural logarithm of 4 plus x squared. So they're asking us to find dy on dx, so that's the A part of the question. Find dy on dx. So this means you should look for the derivative of that function. And so how are we going to compute this? Since it's the log function, remember, if y is equal to the natural log of a function f of x, then the derivative dy on dx will simply be the derivative of the function inside divided by the function itself. So that's actually the condition that we need to use over here. And so from there we can easily have the derivative of that which we have here. So it means my dy over dx will simply be the derivative of this function inside, which is 4 plus x squared. That is the derivative of it, 4 plus x squared, all of that prime means the derivative divided by the function itself, 4 plus x squared. And so the derivative of 4 plus x squared, the derivative of 4 is 0, and the derivative of x squared is 2x divided by 4 plus x squared. So therefore dy over dx will simply be 2x divided by 4 plus x squared. That's all. And so the next one says, the B part says, the equations of tangent, that we should find the equation of tangent and normal to the curve. That we should look for the equation of tangent and of the normal to the curve. So let's call it B. Y is equal to ln 4 plus x squared at the point where x is equal to 1. So we need to compute the equation of the tangent and the equation of the normal to that curve. So how do we go about this? Okay, let's see how to go about this. It's really that easy, but remember, the general equation of a straight line is simply given by y minus y1 is equal to m into x minus x1. Are we together? Where m is the gradient and m can be computed as dy on dx about a point x is equal to a. Are we there? So that's just all that you need to know here. And so we are going to compute the value of y of the ordinate, yes, of the ordinate y1. So computing y1, we simply say when x is equal to 1, y will be equal to ln 4 plus 1 squared, which implies that my y will be equal to ln of 5. And so here we already have the values of x1 and y1, and so x1, y1 will simply have the coordinate form 1 ln 5. Are we together? So from here now we need to compute the gradient, but since from above we already have dy on dx, so we need to compute now our dy on dx about x is equal to 1. So dy on dx about x is equal to 1 tells us I'm just going to substitute 1 in the derivative, and remember our derivative was given by 2x divided by 4 plus x squared, and so about x equal 1 means my gradient will be 2 into 4 plus 1 squared, which is 2 all over 5, and this is what we call the gradient of our function. And so d1 dx about x is equal to 1 will simply give us 2 feet, which is equal to our gradient. That's the gradient of the tangent. So we call this as grad of tangent. Now the gradient of the normal, if two lines are perpendicular to each other, then the product of the gradients m1 m2 will simply be equal to -1. From here we have that the gradient of the normal, that is, if you have the m tangent times my m normal is equal to -1, this implies that the gradient of my normal will simply be -1 divided by the gradient of my tangent, which is equal to -5 all over 2. So that's the difference between the two equations. It's at the level of the gradient. And so from there we can write the equation of tangent. First of all, let's start with the equation of tangent. So the equation of tangent will simply be y minus y1 equal to m of the tangent into x minus x1. But we know our y1 we computed it to be ln 5, and so we have, this implies I have y minus ln 5 is equal to the gradient of the tangent, which is 2 over 5 into x minus x1, which was the initial point 1. And so we have that my y will be equal to 2 all over 5x minus 2 feet plus ln 5. So this is what we call the equation of the tangent. And now for the normal, we simply have equation of normal we have y minus y1 equals to the gradient of the normal into x minus x1. So this will simply give us y minus ln 5 is equal to the gradient of our normal was -5 all over 2 into x minus 1. And so this tells us that from y is equal to -5x all over 2 minus 1 plus ln 5 minus plus 5 over 2, sorry, plus 5 over 2 plus ln 5. So this is what we call the equation of normal. And so the next part of the question is a differential equation. So let's see how to solve this particular type of equation. Okay, so generally this differential equation simply asks us to solve this differential equation, which is given by dy on dx equal xy minus x. And so the question reads that solve the differential equation dy on dx equal xy minus x, given that y equal 2 and x equals 0, expressing y in terms of x formats. So this is what we have. So since the differential equation is variable separable, we are going to separate the variables. So from here, if I have dy over dx to be x, I can factor out x into y minus 1. And so from here we clearly see that I can bring the y terms on one side and the x terms on one side. So I have dy divided by y minus 1 to be equal to x dx. So this is the very first step. And so in order for us to have our solution, or for us to solve it to obtain y in the form f of x, then we simply need to integrate both sides of our equation. And so from here we clearly see that this function which we have, the derivative of the function at the denominator is the exact derivative, or the function which we have for the numerator, which is 1, is the exact derivative of that which we have in the denominator. What I'm trying to say is that we can rewrite this as the derivative of y minus 1 divided by y minus 1, and so which is equal to the integral of x dx. So we clearly see that this falls in the form the integral of dx over x, which gives the natural log of x, and so this gives the natural log of y minus 1, which is equal to the integral of x dx is simply x squared all over 2 plus a certain constant of integration c. And so from here they give us conditions that when y is equal to 2, and x equals 0. So this implies I have ln 2 minus 1 to be equal to 0 squared all over 2 plus c, and this implies that my c will be equal to 0. So therefore I have my differential equation to have solutions ln y minus 1 equal to x squared all over 2, since our c is 0. So from here we have that taking the Napier's number on both sides, that is I'm going to have e to the ln of y minus 1 to be equal to e to the x squared all over 2. And so from here we can clearly see that e to the ln of a, just say but e to the ln a is equal to a. So this implies I'm going to have y minus 1 is equal to e to the x squared all over 2. And so from here my y will be equal to 1 plus e to the x squared all over 2, which is the solution of the differential equation. So that's the end of question 2, and that's what was required of you in the year 2020. So thanks for watching this video, and in the next video we are going to proceed with question 3. And do not forget to click on the subscribe button to stay tuned, and if there is any question which you have, just drop it at the level of the comment box. It shall be attended to. Stay blessed and thanks for watching.